All right, so we have actually 3 different types of arcs, and they're based off of their size. And I'm going to have the highlighter out to show you kind of how they're working, and we'll talk about their measurements. They're not hard to get their measurements, and in fact, I probably changed things up a little bit from what they tell you, just so it makes it a little bit easier for you to remember how to name them. The first one is called a minor arc, okay? A minor arc, okay, is an arc whose points are on or in the interior of the central angle. Basically what they're talking about, this right here, you can see that a little bit, would be a minor arc. It's inside the angle. So a central angle makes it, but here's what you need to remember. The measure of a minor arc, okay, it has to be the measure is less than 180 degrees. So I want everyone to understand the measure of a minor arc, we're going to go is less than 180 degrees. How do you find the measure of the arc? The measure of a minor arc is equal to the measure of its central angle, which means arcs are measured in degrees. And notice, how do I do this? Just like an angle, I put an M in front of it when I'm talking about the mark. So this angle is X degrees, so this arc is X degrees. Guys, that's actually how we find the measures of angles. We use a semicircle, which has an arc on it, to find its measure. So the central angle and its minor arc are exactly the same size. Now the next type of arc we have is a major arc. Okay, major arc is really easy to remember. It's basically everything outside the minor arc. So a major arc is huge, okay? I'm going to do it this way. It measures greater than 180 degrees. Notice I didn't say at 180, because at 180 we have a semicircle, and that's our third type. When you name it, you use 3 points. 3 points. End points and a point in the middle, okay? So when we name a major arc, it's with 3 points. So here, that would be arc ADC. So we use our arc with it. And you notice it's going to be larger than that. Now, this one makes me laugh to go, the measure of the major arc is equal to 360 minus the minor arc. So we just got to take the minor arc away from it to figure its measure. So it's not that hard to do. And the last one is really easy. It's a semicircle. A semicircle is half a circle. The measure equals 180 degrees. So we know that's the case every single time. Now when you name a semicircle, you name it with 3 points too. You name the endpoints E and G, okay, and you name a point in the middle, because it tells you where to go. I go from E, I go to F, and I end at G. And that's actually with major arcs also. I start at my endpoint A, I go to D, I end at C. Now, you could name it the other direction around. You could go arc C, D, A. I start at C, I go to D, I end where? At A. So you can name it either endpoint first, but when you have a major arc or a semicircle, you have to use 3 points to do it. Now, and this is just reiterating what I said. You know, minor arcs must be named by 2 points. Major arcs and semicircles must be named by 3 points. So we'll keep it really good. So let's just go ahead and name the different parts here of this one. This is on this one, we talk about diameters. Now, I know I don't really talk about the diameters much, but it's because I kind of already expect you know what a diameter and a radius is, and I'm going to refer to them, I promise, later in the lesson. But remember, the diameter just goes through the center, and a radius goes from the center to the edge of the circle. Now, it says on the first one, name 2 major arcs. So remember, it has to be larger than 180 degrees. So when I do that, real easy, I'm going to start at A, and I'm going to end at D. I'm not going to go the short way, because that's a minor arc. I'm going to go long. So I'm going to go arc A, F, D. Start at A, go to F, end at D. So it's a large part. Another one you can name would be something like, I like this one, B, F, A. I start at B, I go to F, I end at A. So that would be some major arcs. A pair of adjacent arcs. Now, I didn't use that terminology, but I'm going to go down here and actually fill it in, okay? Adjacent means what? That's right, next to. So adjacent arcs actually share the same endpoints, but nothing in the middle of them. So adjacent arcs, and make sure you know what that definition is, are arcs of the same circle that intersect at exactly one point. These two arcs right here, this arc and arc ST, would be considered adjacent arcs because they share endpoint S, but that's it. There's nothing else that they have. So I need to have two arcs that have a point in common, but nothing else. An easy one to name for there would be like arc AB and arc BD. Those would be two very easy ones to do. Now, how about two semicircles? All right, two semicircles. You can do this and you can name it when you have a diameter because that lets you know you're divided exactly in half. So let's use the diameter AE here this time, okay? So I know I have to start with A and end with E, but I don't know if I'm going to go to this side or this side, so I have to name a point. How about if we do the bottom part first? So when I name it, I'm going to start at A, I'm going to go to B, and I'm going to end at E. So that tells me arc ABE, this semicircle. So when I name the other semicircle, I'm going to go to the top part this time, and actually I'm going to start with E because I just feel like it. I'm going to go E to F, and I'm going to end at A. And that's the other half of our circle. So that's the two semicircles. The next one, you're supposed to name two minor arcs. Remember, a minor arc is just less than 180 degrees. So arc E, no, let's go arc EF, arc BD, or you could say arc AB. And then so you say that and you see just 2 points, you know you're talking the small ones. Arc, DE, any of those. Now it says name an acute central angle. So an acute central angle, so a central angle is formed by two radii and it has to be less than 90 degrees. I'm going to do angle BCD. A central angle has to have a vertex on the center of the circle. Otherwise, that's a central angle. An obtuse central angle, I'm going to use the one that's larger than 90. So I'm going to use angle ECB, this one right here. Obtuse central angle. Hopefully that will help you a little bit with those. And now we're going to flip to the other page. And then we are going to go ahead and work with some measurements and stuff of these as we're going. So I want to give you a second more to write it down. And we're going to flip our page.